So here we have a completed machined part that's been machined from a shape, very similar to what I made a while ago with casting and forging, tapered and filleted designs. And if we take a look at this process, what I've done is I've used the insert part option in order to bring in this sand cast part. You can see if I look at front view, right view, top view, you can see the tapers and the heavy fillets that are used for this particular component. And so I've gone through the process also of bringing in other bodies. This one that would give us the shape of a connection that might be used in a heavy industrial application. And I've inserted these bodies together. Again, if you need more information on using multi-body solids, we've got some other videos on Pluralsight to describe these procedures, these techniques. But you can see I've got these intersecting bodies that are in here. And then I've also got some other cut features where we're machining down, setting in some patterns for some bolts, boring some holes in the part using traditional revolves, sweeps, extrude cuts, and a toolbox feature. And then I finish that off using a combine feature, the subtraction option. And that is where I'm subtracting these library bodies, these library parts away from a machined component like this. But it's all built in the part environment wherein I insert my casting or forging using insert part, doing that one at a time for each of the ends that are associated, and then machining the features away. What this gives you is a very manufacturable or very repeatable process. I'm actually emulating the manufacturing process while I'm designing these parts in SolidWorks. And one of the things I've taught my students over the years is that you should model it in SolidWorks the way it's built in real life, and do that as much as you can. In doing so, you're already testing the manufacturing process before you get there, and you'll be a better designer having known the processes that are being used in order to create your geometry. So let's just take this a step further. How did I create the casting or the forging? In this case, it's a sand cast part. How did I create that in the first place? So we use a sand casting process wherein a board is typically cut out of, say, a mahogany or some high density strong board to give us the shape on either side of our mold half. So in this case, we've got the top half and we've got the bottom half. I've created some additional features for a cup and a sprue, a gate, to allow the molten metal material to pool before it goes into the general cavity. This is something a mold maker would typically do as part of their process. That board is placed, and then a metal ring is placed on top of that. And then a sand that will compact and stick together is placed into the mold ring and formed into place. And so what this gives us is mold halves that have an impression on part of the geometry that we want. You see I've added a hole here where the funnel, where the molten metal are actually going to be poured into place. So I've got a little bit of a motion study here to show you a little bit of what that process would look like. The form board is taken out from the middle of the mold halves. They're resandwiched together. Metal is poured into place, and then the sand is shaken off of the casting, leaving us with a moldable part. And this is part of the reason why the fillets and all of the tapers are needed, is to give us a demoldable part that makes it very easy for us to produce and manufacture. And ultimately being able to take that into a set of tools, machine it, and give us a completed part. So whether you're doing sand casting or whether you're doing a closed die forging where this shape would be hammered first from a piece of heated up billet, or whether it's cast using molten metal like we've shown here, you're able to produce the geometry that's needed and then machine that afterwards, making it a very efficient manufacturing process.